These are your 2-5 notes on solving equations with absolute value signs. So we've been working this whole chapter on solving equations. So a lot of the similar techniques are going to apply. But now we're going to solve equations that have an absolute value symbol around them. And it just creates a little bit more complications. So first of all, let's talk about what an absolute value is. An absolute value is the distance a number is from 0 on the number line. It can't be negative because it's distance. And so if I was to put a point here at 5, call that point A, what I could say is that the absolute value of point A is equal to the absolute value of 5. And what you're saying is how far away is 5 from 0? And so if I count back to 0, 1, 2, 3, 4, 5, it's 5 units away from 0. If I were to put a point here at negative 3, negative 3, the absolute value of negative 3 is asking, these lines around it is saying how far away from 0 is negative 3. And when I count back, it's 3 units away from 0. So it's a distance. You're measuring how far a number is away from 0 on a number line. And then the other thing I want to mention here is that every number to the right of 0 has a matching buddy to the left that has the same absolute value. So we said that 5 has an absolute value of 5, but negative 5 also has an absolute value of 5. It's just 5 units to the left. So every number that's to the left is also to the right. So there's always 2 that have matching absolute values. Negative 5 has an absolute value of 5. It's 5 units to the left of 0. And positive 5 has an absolute value of 5. It's 5 units to the right of 0. Negative 3 has an absolute value of 3. And positive 3 is also 3 units away from 3. The only number on the number line that doesn't have 2 values or 2 distances away from 0 is 0 itself. When you take the absolute value of 0, you're saying how far away is 0 from 0? Well, it's 0 distance away. It's right on the actual mark. It works for fractions. It works for decimals. Every number that has an absolute value to the right has a matching buddy that has the same absolute value to the left. The only number that only has one absolute value is 0. So we're going to evaluate these things, and then we're also going to solve these things. So the difference, when we say evaluate, we're going to find the value. We're going to actually have, I'm going to be given a value for the variable. We're not solving for the variable. Notice there's no equal signs in these. It's just plugging in and simplifying. Okay, so when we evaluate these things, we follow the order of operations, PEMDAS. You simplify first what's inside the absolute value and then take the absolute value of that number. So you try to, for instance, in number 1, before I take the absolute value, before I change anything and do distance, I got to know what distance I'm finding. So because it's a subtraction problem in there, I'm going to do the subtraction and then take the absolute value of whatever the difference is. You cannot distribute. Okay, the distributed property does not work. It will work sometimes, and it won't work other times. And so because it doesn't consistently work, we cannot use it. So if you have a number out in front of the absolute value where you're multiplying, you just have to take the absolute value, then multiply it. You cannot distribute it through like parentheses. So let's look at this first problem. H is 5. So I'm going to replace H with 5. And then I'm going to subtract 3 and 5, which gives me negative 2. I'm going to put the absolute value symbols around it. Now that I have a number inside the absolute values, I'm going to identify what it's saying. It wants me to take the absolute value of negative 2, or it's asking how far away are we from 0. If we're at negative 2, we're 2 units away from 0. Plus 3 is 5. So we simply just get an answer there. For the second problem here, G is negative 4. So I'm going to replace, oh, my board's off. Give me 1 second here. All right, so I had to calibrate my board. 16, take away negative 4 plus 9 inside the absolute value. So like I said before, I'm not going to take the absolute value of -4 and the absolute value of 9 and then add them. It wants me to treat it like a grouping symbol. We have to do that first. So I'm going to actually add -4 and 9, which I get +5. The absolute value of 5 is saying how far away is 5 from 0, which is 5. And so 16 minus 5 is 11. Okay, so you do have to show me what happens from this step here where I have the absolute value symbols around it to this step is evaluating what that is. Okay, you're telling me what you're answering what those symbols, those two lines represent. And the last one, I have variables for all of them. So inside the absolute value, I have 3 plus a -4, and then on the outside, -5. When I add 3 and a -4, I get the absolute value of -1, take away 5. Before I can do the subtraction, I got to figure out what I'm subtracting. I'm subtracting the absolute value of -1, which is the distance that -1 is away from 0, 1. Take away 5 is -4. There you have it. That's evaluating. When we solve these things, because there's two different numbers on the number line that could possibly have the same absolute value, you're going to solve using inverse operations. You're going to solve two equations for the absolute value equations because there's two numbers that have the same absolute value. Both equations and graph solutions on the number line. Oh, I forgot. Duh. So we're going to isolate the absolute value using inverse operations. What we want to get is absolute value equals some number. Once we know what the absolute value equals, what number, we know that there's two numbers that have that absolute value. So we're going to write two equations. One with the absolute value to the right and one with the absolute value to the left. We solve both and we're going to put the solutions on a number line just so you understand. So it says to solve, then graph the solutions on a number line. All right, so this first one, number 4 here, it says some number plus 7, the absolute value of a number plus 7 is equal to 5. Well, I know that on the number line, there are two numbers that have an absolute value of 5. So I'm going to interpret this, and I'm going to write two separate equations, and that's going to get rid of the absolute value. I know that there's a number, n plus 7, that must equal 5, because 5 to the right has an absolute value of 5, or this stuff inside the absolute value must equal -5, because 5 units to the left also has an absolute value of 5. So I'm taking the stuff inside the absolute value, and I'm saying, well, the absolute value of 5 would give me 5, and the absolute value of -5 would give me 5. So I wrote an equation so I don't have to think this through in my head, and I can have the algebra do the work for me. I got to make n plus 7 equal 5, and I got to make n plus 7 equal -5, because those are the two numbers on the number line that have an absolute value of 5. So when I do this, if I subtract 7 from both sides, I get n is equal to -2. And for the other equation, if I subtract 7 from both sides, I get n is equal to -12. So the two numbers on a number line, here's 0. I just want to kind of, well, actually I don't need to even put 0 on there. I don't need 0. I just need the two numbers on there. Just make sure that -12 is further away than -2. If I add -2 to 7, I get +5. And if I add -12 with 7, I get -5. So all you do is you put those two on the number line, and we recognize that those are the two solutions. Number 5 here, same thing. I know that there's two numbers that have an absolute value that's equal to 9. If I'm 9 units to the right, I know that the absolute value of 9 is 9. And I also know if I move 9 units to the left, -9 also has an absolute value of 9. So since these two absolute values equal 9, this stuff inside the absolute value must equal 9 or -9. So those are our two equations. 3z minus 3 equals 9, or 3z minus 3 equals -9. I'm running out of room. I'll probably put 6 on the next slide. So when I solve this, it's two equations. I'm going to add 3 to both sides. 3z is equal to 12. Divide by 3, divide by 3. Z is equal to 4. And then the other equation, I'm going to add 3 to both sides. 3z is equal to negative 6. Divide by 3, divide by 3. Z is equal to negative 2. Now I know 4 doesn't have an absolute value of 9, but when you multiply 4 by 3 and subtract 3, it equals 9. And I know 9 has an absolute value of 9. And negative 2 is not an absolute value of 9. But when you multiply negative 2 by 3 and subtract 9, you get negative 9. Okay, so what I want you guys to remember is when you see these absolute value signs around an equation, they're different than other equations we've solved. When you see 2 lines, I want you to think 2 equations. 2 lines, 2 equations. You also should be checking these solutions. So I've been kind of plugging them in as I go. I checked the blue in my head. When I checked the red problem, z is 4. 3 times 4 is 12, minus 3 is 9. It works. When I check negative 2, 3 times negative 2 is negative 6, minus 3 is negative 9. It works. You have to check these. You have to do a formal check, but you better check because sometimes we get a wrong answer and we did nothing wrong, but it ends up being wrong, and that's called an extraneous solution. So you have to be careful of that. That can happen only in absolute value functions right now. The regular function equations that we solved, it can't happen to, but in these particular equations, it can. So we have to be aware of that. All right, so I'm going to actually write this equation on the next page so that I have a little bit more room. Okay, so 4n, the absolute value of 4n minus 1 is equal to negative 6. So I know that there are 2 numbers that have an absolute value of 6. I know that 6 has an absolute value of 6, and I know negative 6 also has an absolute value of 6. The problem with this problem is it's not saying we have an absolute value of equal to 6. It's saying negative 6. There's no such thing as a negative absolute value. So be careful here. If I see absolute value equals negative, there's no such number, no solution. I know that I can say 6 and negative 6. I could solve it, but when you go through and solve a problem like that, it'll give you the wrong answer, and so you could get no solution as well. So just be careful. Sometimes we get into the repetition of a problem, and we don't realize what we're saying. Number 6 is saying that an absolute value is negative. That does not happen. All right, so give it a shot here. I want you to evaluate that first problem using the order of operations, and then I want you to solve this absolute value. Now, I will get you started on this one. I didn't show you any where there was a number with the absolute value. So before you write it into 2 separate equations, we need to isolate the absolute value. We need to get this thing by itself. And so I'm going to add 3 to both sides first. That gives me the absolute value is equal to 5. Absolute value of x plus 1 is equal to 5. And then from there, you should be able to write your 2 equations. Good luck.